Hello, this is chapter 4, video number 3. In the previous few videos, we talked about two variable statistics, scatter plots, and the correlation coefficient. And now we are going to be learning how to calculate the line of best fit, or sometimes called the least squares regression, or the linear regression. We've got several different words that we can use to describe it. But before we get into calculating, let's talk about what it is. So first things we have here is we have a sample. We have a sample of data, and what we have here is we have years since 2000, and finally the profits of some company in thousands of dollars. So let's say it is a small restaurant. So it opened in 2000. Here is the data. On every year. And I went ahead and made the scatter plot for this as well. So this right here would be the year 2000 when it made $53,000. This is the year 2001, it made 141,000. 2002, 2003. All right, now let's say that we would like to describe, okay, well, what is the general pattern here? What is going on? And one way to do that is by making the least squares regression or the least squares line or a linear regression. And essentially what that is we're going to try to come up with an equation, a line of best fit that goes through that represent not necessarily goes through but represents this data the best. So obviously this would not be a good line of best fit because it doesn't really fit the data. We would want it to go somewhere in here, probably trying to minimize those distances. Looks pretty good. Now, this can be done by hand, but it might be a little bit much for this course. But here's what we're essentially trying to do. We're trying to minimize the distance of each of these. We're trying to minimize that distance as much as possible and making this fit. All right, so let's go ahead and talk about how can we use technology to calculate this line? How can we use this technology to calculate? And I recommend my good friend Desmos. So Desmos here. You will go to desmos.com/calculator. All right, and I encourage you to do that now and maybe try to follow along with this video. And what you're going to do is you're going to add an item. You are going to go ahead and add a table. Add a table here. And what you're going to do is type in these values. Type in the values that you have over here. So I have 0, 1, 2, and 3. And I had 53, 141, 110, and 187. And before you do your homework, I'm going to strongly encourage you guys to double check to make sure you typed in everything correctly. You don't want to miss something just based off of a typo. All right, so now the command that you are going to do here, if you've done this on a graphing calculator, you might remember calculate, two variable statistics, linear regression, add table. This might be a little bit easier. So here is what you are going to type. First off, most equations of lines are written in the form y equals mx plus b. It's not my favorite equation of a line, but it'll do. So here's what you're going to type to calculate how can we predict y sub 1 in terms of x sub 1. So here we go. So y, and you're going to do an underscore 1, is approximately mx sub 1 plus b. Ooh, all right. So real quick, y1 is what we're trying to predict. M is our slope. X1 is our input, and then finally plus b. All right, and here is what we have. Our parameters, we have m equals 37.1, b is 67.1. So this is our prediction. This is our model. So if I were to write this, as an equation of a line, all right, if I were to write this as an equation of a line, first off, my slope is 37.1. Our y-intercept is 67.1. All right, and I'm going to come back over here and write this as an equation. So first off, if I want to just do this in terms of x's and y's only. Here we go. All right, so first off, a line of best fit. We don't just write y, we actually write y hat. This symbol simply tells us that, hey, this is a prediction. This is a prediction. This isn't the actual value. This is just our prediction based off of our linear regression. Our slope is 37.1 times x plus 67.1. All right, and I got that data from Desmos. I got those calculations using Desmos. My parameters, my slope was down here. My y-intercept is 67.1. And you might actually see your R value right here, what we talked about last time. Our R value is 0.85. That tells us that we have a pretty strong positive relationship. All right, so this is our line of best fit. This is our equation of our line, y equals mx plus b, slope y-intercept. And in our next two videos, we're going to talk about, okay, well, what can we do with this? What does this tell us?